Da, da, da. We're going live on Space Radio. WCBE. Oh, no, don't end. We'll figure it out, folks. We'll figure it out. Oh, I messed up. I hit a button to delete the video as soon as I started it. We'll get there. We'll get there. Save. All right. All right. Here we go again. Everyone's connecting. Facebook is connected. YouTube is connected. Going live. If you're just now tuning in, wait a little bit while we figure it all out. All right, Facebook is live, I think. And YouTube's live. All right, ready to record? You're rolling. Live from Earth, it's Space Radio. This is Paul Sutter, and coming up, we're talking about gold. Sweet, sweet gold. All you have to do is go in the middle of a neutron star merger explosion. How easy is that? And of course, we're taking listener questions about all things, because this show is about the entire universe. We record the show every Thursday at 4 p.m. Eastern, so call 888-581-0708 to join the conversation. And in today's Blue Shift, I'll be talking about a science fiction show that I'm finally getting around to watching. But first, the news. Hello, space fans. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Ohio State, chief scientist at COSI, and for the next half hour, your agent to the stars. We've got an exciting show for you today on Space Radio, where we talk about all things space, astronomy, astrophysics, rocketry, science, and society. If it's above the Earth's atmosphere, even if it's in the Earth's atmosphere, it's in this show's universe. This show lives on listener questions. We record every Thursday at 4 p.m. Eastern here in Studio A of WCBE Radio Columbus, so call 888-581-0708. Light it up. Get those calls in. We'll have a nice little chat. You can also follow along on our live streams on YouTube and Facebook. Go to spaceradioshow.com for all the links. You can also follow me directly on Twitter and Facebook. My name is at Paul Matt Sutter. Seriously, folks, I've only prepped 10 minutes of show material, tops, so get those calls in. Before I start taking calls, though, I want to share some interesting bits of news I caught recently. And the announcement from a couple weeks ago of gravitational waves being detected from the merger of two neutron stars made, are you ready? It made a lot of waves. I could not resist the pun. And still, I went to look for more recent news, what's something new to talk about. I've been talking about gravitational waves for a while. Like the entire last episode was totally dedicated to gravitational waves. And you know what? Gravitational waves are still in the news every single day. It is ridiculous. There's just so much going on. So many discoveries, so much more new knowledge, so many more new questions revolving around this discovery, and I want to highlight one of them. Chances are you have gold on your hand, right? Maybe it's around your ring, maybe it's around your neck. You've got gold somewhere on or possibly pierced through your body. Where did this gold come from? We know where elements come from. Hydrogen and helium and a little bit of lithium were formed in the first few minutes of the Big Bang, 13.8 billion years ago. Other elements like carbon and oxygen are fused inside of stars like our sun. Right now, our sun is turning hydrogen into helium as a part of its life cycle. And towards the end of its life, it will fuse helium into carbon and oxygen, and then it will die. That's another show. Bigger stars are able to fuse heavier elements like silicon, magnesium, nickel, and iron. But at iron, the fusion chain reaction stops. Stars are unable to extract energy from fusing elements heavier than iron. That's what triggers what's called a supernova explosion. In the remnants of that explosion, the tremendous energies released during one of those explosions that can fuse heavier elements, elements heavier than iron, like silver, like platinum, like gold, like all the radioactive elements. And we knew for a long time that supernova were responsible for a lot of the heavier elements. And there was this open question of whether merging neutron stars, which are also very energetic and release a lot of neutrons that can be used to build heavier elements, if they played a role in the genesis of heavier elements too. And it's been conjectured for a while, about 20 years it's been conjectured. And finally, with this gravitational wave discovery, we know for sure that neutron star mergers play a role in the formation of heavy elements. That's because through gravitational waves, we knew 100%, without a doubt, that this is a neutron star merger. And then we were able to follow up with other observations to look at the aftermath of the explosion. And when we look at the light, we can see the elemental fingerprints in that light. We can detect gold. In fact, 3 Earths worth of gold was produced in that single explosion. And so does that mean that the gold here on Earth formed from a neutron star merger billions of years ago? Maybe. We don't know how common neutron star mergers are versus supernova and how efficient they are producing various kinds of elements. We're still working on that, but at least plays some role. So that's the latest and greatest when it comes to space. Think on that the next time you're at a jewelry shop. And it's time to have a conversation. All right, guys, I'm going to call
the notes didn't say, but it's you have a call. Carson wants to follow up on an expanding universe question.
Okay, very cool. So I'm going to take, I'll bring in my guest, and we'll answer the question together.
Okay, you're gonna bring him in live then, Carson?
Right now I'm gonna bring in John Michael, the guest.
Okay.
I'll bring him in live, and then I'll bring in Carson.
Okay.
And YouTube is working great.
Oh, good.
Oh, hey, that's good to know. Hi, YouTube. Good to know. All right, Carson, I bet you can hear me. So I actually have a special guest on today's show, a sci-fi author and YouTube host. I'm going to bring him on, and we're going to answer your questions together. So we just have to give him a quick little call.
Hello.
Hey, John.
Hey.
Can you hear me all right?
Yes.
All right, so good. So we've got 2 segments, and we actually have a caller already on the queue with a space question. And if you want, you can answer the space question with me. I have no idea what the question is going to be.
I will try and help if I can.
We'll make it up as we go along. So I'm going to start the segment, and I'll introduce you. Is it Godier? Pronunciation of your last name?
Godier, yes.
Perfect.
Yep.
So I'll go ahead and start the segment, and I bet you'll figure out when to come in.
Sure.
On Space Radio, welcome to Space Radio. I'm Paul Sutter, and we have a very special guest for today's episode. We have John Michael Godier. He is a science fiction author and a YouTube personality guy. He's super amazing. His videos are awesome. He has a passion for communicating science. He's been talking about space exploration and astronomy for over 3 decades, and he loves hard science fiction. He's going to tell us what that means. He's dedicated to presenting sci-fi in terms of the possible rather than the fantasy. John is also an advocate for education in science, spreading the word that humankind must stretch its wings and explore the universe from here on Earth and in space. His YouTube channel shares his name, and it is dedicated to astronomy, SETI, and the possibilities that exist in the universe from the perspective of a science fiction writer, which is such a cool perspective. He's also the host of the upcoming podcast and YouTube channel Escape Velocity, the official broadcast of Enterprise in Space, an educational project of the National Space Society, a nonprofit that intends to launch student-designed experiments into space. Man, that is so much awesomeness going on. Thank you so much for joining me on the show, John.
Hi, Paul. It's great to be with you.
And my first question for anyone who's a geek about astronomy and space, what got you started on your path to geeking out about space and astronomy?
The answer is actually very simple. I think I was about 10 years old, and I saw the planet Saturn through a small telescope. And I was absolutely blown away.
Did you see the rings and the gap between the rings and all that?
Yes, you could see it, and it was just obvious. And I have never looked back since. I've been an amateur astronomer since that time, and sort of a science fiction enthusiast. But I was one of those people that procrastinated about writing a book. You know, I always wanted to do it, but I never did it until 2012, when I wrote my first book. And what motivated me there was that there really wasn't enough hard science fiction out there.
Could you define what hard science fiction means?
Sure. Hard science fiction is when you tell a story based in solid science. Instead of just making things up like faster-than-light travel or things that we don't think are possible, that's fantasy, ultimately. But when you build your world within real physics, then that's hard science fiction. And that used to be...
Is it called hard because it's very difficult?
It's hard. Well, it is difficult, yes. But it's called hard simply because it's based in hard science. And this is stuff like Arthur C. Clarke, you know, that talking about, say, a space elevator or something like that, something that could be. And that's what I do. I wanted... originally, when I started that book, I wanted to tell a story using realistic spacecraft physics. In other words, if you come across a derelict spacecraft and it's spinning out of control, how do you slow it down? So I used realistic physics to do that, and ultimately to tell a story about space salvage and how you would go about doing that, how you would deal with the physics, what the mechanics of it all.
I have to interrupt you because you can't leave me hanging. How do you slow down a spinning spacecraft? I need to know now. You know, just in case.
Same way that NASA adjusts how their satellites spin. You just do it with essentially two weights on lines that you release out, and that will actually slow it down. And if you could magnetically attach such a thing to a spinning spacecraft, you could theoretically slow it down that way. But so that's the main way.
Well, that's good to know. I'm gonna keep that in my back pocket because you never know when that will come in handy. So you wrote another book.
Really,
yeah, you never know.
You never know. Well, the other way to do it is to blow the ship up and just get the contents. If it's a mineral or something like that, you could do it that way too.
That sounds very smart.
I chose to actually
like that.
slow it down.
Brutally efficient.
Yes.
So why were you drawn to hard science fiction rather than just writing a book and making stuff up as you went along?
Very simple. A strong interest in science, and it just seemed to me there was just something wrong about writing, fantasy, making, again, faster than light travel and these sorts of things that you see in sci-fi. Just didn't feel right to me. I thought, well, I'll just do it, the way it really is. And it would make for, or at least I hope it would make for a more interesting story. The other thing is that not a lot of people were doing that when I started. It had kind of devolved to where fantasy was the rule, and it's all you saw in the market.
Mm-hmm.
Now that's changed, of course, since then. I think Andy Weir with The Martian changed that
Right.
landscape a lot. But back when I was first started, there was very little, and the authors were dying off. Arthur Clarke and Asimov were gone, and no one was replacing them. So that's sort of what I set out to do.
Very cool.
Not as good as they were, of course.
Hey, I'm not going to judge. We actually have to take a quick break. Don't forget to call 888-581-0708 to join the conversation or catch the live streams on YouTube and Facebook. Visit spaceradioshow.com for all the links. We have science fiction author and YouTube video host John Michael Godier here on Space Radio. This show is brought to you by you. Visit patreon.com/PMStar to learn how you can support the show. Stay tuned. There's more after the break. And there's our pretend break. The second section will be a little bit longer. But
Okay.
This is good stuff.
Fantastic.
Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. We have a special guest on today's program, John Michael Godier, a YouTube video host, an explainer of science, and an author of science fiction. Not just any science fiction, hard science fiction, which means it's based in real science. We were having a conversation before the break, and you were telling us about what motivated you to write hard science fiction versus just what you consider fantasy or just making stuff up. And I want to turn the conversation to your YouTube videos. What made you want to start a YouTube channel? Of all things, a YouTube channel.
Well, funny enough, I'm one of those people that YouTube has sort of become my television. There's so much content there to watch that you don't really need to watch cable so much anymore. And what I saw was an opportunity. I thought, anybody can do a channel, and I could probably do a pretty good one and talk about something. I didn't know what that was, but I thought I could talk about something, and talk about my books too. And I'd initially thought about doing a sci-fi channel, doing book reviews or something like that. But what changed the equation was I noticed that YouTube had a lot of pseudoscience videos and a lot of sensationalist videos dealing with science. I didn't care for that much. I thought,
imagine that. I would have never guessed.
Exactly. And I eventually just got driven nuts by it, where I would see things misreported, science stories. And I thought, well, you know what, I'm just going to go in and report the actual science, not sensationalize. And there's plenty of interesting stuff to talk about, that. So I just went ahead and did it that way, and haven't looked back.
Nice. What are some of your favorite topics to talk about on your show?
Well, there is one major favorite. I am absolutely fascinated with the concept of ice shell ocean moons like Europa, Ganymede, and Enceladus. They just fire the imagination for what could be lurking in there.
Space
so
whales.
That's definitely my...
Space whales are lurking in the subsurface oceans of the gas giant moons.
Space jellyfish. And so that's probably my favorite. But another strong contender would be SETI and the Fermi Paradox.
Could you give us a 30-second intro to the Fermi Paradox? Go.
The Fermi Paradox is an idea by Enrico Fermi that the galaxy has been here for billions and billions of years. Plenty of time for a civilization to have developed. And if they had done that, had they arisen, they could have colonized this galaxy in that time. But when we look, we see no evidence of it.
Nobody.
We see no evidence. Everything looks completely natural. Why is that? And that, in a nutshell, is the Fermi Paradox.
Nice. That at first blush, that does appear to be a paradox. What's your favorite answer to the paradox?
It's my suspicion is that the universe is teeming with life. Trouble is, most of it's microbial, and that intelligent life is exceedingly rare. And you need only a very specific set of conditions to allow for it to arise. And even if it does arise, there's no guarantee that it can found a civilization, or at least a spacefaring one. Say, for example, it lives on a super Earth with a gravity well, too great to use rocketry. So that, my suspicion, though, in a nutshell, that it's just very, very rare.
Are we the only ones in the galaxy?
We could be.
Man, that's sad.
But you also have another problem with that, too, time. We may not be alone, it's just we're not existing at the same time as another civilization. Maybe they existed long ago and they're gone, or they're not here yet. So you have both a time dimension and a distance dimension. And just so many things stacked against it, I would say. But I don't think we're alone in the universe. The odds are still in favor of there being someone else out there.
When you add up all the stars, all the planets in the whole entire universe. We actually have a caller calling in. Would you like to answer this? I have no idea what the caller's going to ask. Would you like to answer the question with me?
I will do my best.
We're gonna make it happen. Some real radio magic is about to happen. Hey, Carson, thanks for joining Space Radio. Can you hear me all right?
Yes, I can.
All right, Carson, thank you so much for joining us. What's your question today?
Well, first of all, I want to tell John, thanks for the hard science. I think that's much more fascinating than just making things up that may not exist at all. But on the other hand, really, truly, in this wonderful age that we're in, real science is much more fascinating than anything we can conjure up anyways.
I agree very much. Thank you, sir.
No, thank you. And then, Paul, here's a plug for you, but it's sincere from the heart. Thanks a lot for getting on the weekly Space Hangout. I watched that, and I really enjoy your comments on that.
Oh, thank you so much. I really appreciate it. That's a YouTube show I do with Fraser Kane. John Michael was a recent guest. Or no, you've been on Weekly Space Hangout, haven't you, John Michael?
No, actually, I have not, believe it
What?
or not.
Fraser
no,
connected us.
I,
Fraser connected us, but oh man, we got to fix that.
Well, I have a super secret YouTube project going with Fraser, so that's where that comes
from. I see how it is.
But I can reveal no details.
Oh, you're killing me. Okay. Carson, what's your question?
It's about space.
Okay, this question is a follow-up actually to a prior broadcast of yourself, Paul. And it has to do with the expanding universe.
Mm-hmm.
Now, I have no science background, so this is just off the cuff.
Go for it.
Well, the idea is that if we believe the universe is expanding equally in all directions, I have a problem with direct observation with the local solar system that we're in. It does not seem to be expanding in that way. And just to appeal to authority, I think it was Einstein that said, if direct observation does not seem to jive with a concept, the concept is probably wrong. And so then I have one other question after that, and then I won't bother you guys anymore.
We may only have enough time for the first question. We'll see how quickly I can answer it. We do believe that the universe is expanding equally in all directions. The solar system is not expanding. The Milky Way is not expanding. You only notice this expansion on extragalactic scales, on cosmological scales. And that's because galaxies and solar systems are gravitationally bound. If the universe, if space-time itself has a tendency to expand, you can overwhelm that tendency to expand with simple gravity. And so our solar system and our galaxy stay bound together, but galaxies themselves are separating away from each other.
Okay, hey, that's cool. I can see that. My next question is probably pretty direct. With all the buzz about the universe expanding, why couldn't that simply be a function of the second law of thermodynamics?
You know what? There is, and you know what? I'm going to have to devote a whole other episode to this because there is a connection between the expansion of the universe and entropy thermodynamics. The universe started in a low entropy state and has been increasing in entropy ever since. Things have been getting more chaotic ever since. That is actually a fundamental mystery in our universe that we don't fully understand. But unfortunately, in the tight time constraints of this radio show, I can't answer today, but I would love it if you called back next week and we can really dig into that. Does that sound like a plan, Carson?
Cool. I appreciate it.
All right. Thank you so much for calling. And I still have John Michael Godier on the line. And you know what? The very last part of the radio show is something I call the Blue Shift. And I was planning on talking about the sci-fi show, The Expanse. Would you like to join me for the Blue Shift, John?
Sure.
All right.
Although, unfortunately, I have not yet seen The Expanse. Everyone tells me to watch it, but I'm sure I can say something about it.
Okay. We'll make it happen. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift. This is my opportunity to get a little bit closer to you. And I wanted to talk about a TV show on the Sci-Fi Channel that's based on a book called The Expanse. And I have a guest with me, John Michael Godier. He is a science fiction author and a host on YouTube. He has an amazing YouTube channel presenting science facts from the perspective of a science fiction author. It's such a fun combination. Now, John, have you ever seen The Expanse? I know it's been out for 2 years. I just binge watched it last week. I just finally caught up.
It's on my binge watch list, but I have not yet seen it.
Fair enough.
I can't wait, actually, because I don't get to watch enough sci-fi on TV, to be honest.
Have you read the books that they're based on?
No, I have not. I've been aware of them for a while, but I just haven't gotten to them yet.
I think,
unfortunately, there's so much literature.
There's a lot going on. I know.
You can read for a lifetime and not get it all.
One of my favorite things about The Expanse is the plot and the action and the space stations blowing up and all that good stuff. But how they treat the physics. When you look at a aircraft blazing through the atmosphere and they make these big banking turns to turn around. A lot of sci-fi shows show spaceships moving around like that, making big banking turns and just acting like they're in the air or acting like they're in the water. But space is completely different. How would a real spacecraft change trajectories?
Well, equal and opposite reaction. It would have to have something pushing it in another direction in order for it to change directions. So you would use like what we use with NASA spacecraft. You would use thrusters, or you might even use gravity assist. But really stopping a spacecraft on a dime, you need a lot of energy. So whatever you would use definitely would not involve an atmosphere, however, unless you were actually entering an atmosphere. And when you see that, those banking turns and things like that in space, it's just silly. It makes no sense. But when you see lots and lots of thrusters firing, that's where it gets realistic.
That's where very good to hear. My guest today has been John Michael Godier, a science fiction author and a YouTube host. John, what are the names of your books? Where can people buy them? And where can people watch you on YouTube?
On YouTube, you can find me at John Michael Godier. Just search my name, Godier. And you can find my books at Amazon or any online retailer in both paperback and ebook formats. And the books are named The Salvagers, which is a space opera, and the new book, just out just a few weeks ago, is called Supermind, and it's about artificial intelligence and the dangers of it.
Very cool. Thank you so much for joining me today on Space Radio.
Good to be with you, Paul.
Thanks. Bye. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of Space Radio. Once again, I'm Paul Sutter, and this show is brought to you by the Ohio State University Department of Astronomy. Learn more at astronomy.osu.edu. This show is also brought to you by you. Visit patreon.com/pmsutter to learn how you can contribute. Thanks to Greg Moebius for producing, Dan Michalko for being awesome, and all the fine crew at WCBE Radio for making this show possible. We record the show every Thursday, 4 p.m. Eastern. You can call 888-581-0708. Join me on the air and catch the Facebook and YouTube live streams. Go to spaceradioshow.com for all the info. Thanks again, Earthlings, for listening. See you next week. End of transmission.